All right, this is chapter 6, lesson 1. Make sure you're paying attention. And that means you too, Sebastian, since sometimes you don't like to watch the videos. Let's just make sure you're paying attention, mister. All right, I've just got one example. I know this is example 3, but I already did the other examples during class today. So just continue in your notes where you wrote today how to change mixed numbers to fractions and fractions to mixed numbers, okay? So right below that, you're going to write example 3. That's fine, subtracting with variable expressions. I just want to now show you how to do this with variables. All right, so here we go. 6x minus negative 3x equals 6x. We're just changing the subtraction to addition. Then you change the negative to the opposite, so it becomes positive. So I just have 3x right here, 3x over 5, no negative, right? So now all we have is 6x plus 3x is 9x here. And the denominator stays the same, 5. So 9x over 5. Okay? Same that you guys have done in the past. As long as the denominators are the same, you just add or subtract the way you normally would. Okay? All right. So here what I'm going to do is write an addition problem. So, how much is the first circle represent? This circle here represents how much? Some of you might say 2 out of 4. Some of you might say 1/2. Both of those are correct. So I'm going to say 1/2 plus, now this one, what does this represent? 1 out of 4 looks like to me. 1 is shaded out of 4 parts total. So 1 is shaded, and we have 4 parts total here. 1, 2, 3, 4, right? When I add them together, I get 3 parts shaded out of 1, 2, 3, 4 parts total. So that means 1/2 plus 1/4 is equal to 3/4. Okay? That's your answer for that one. The next one. Now we have a subtraction problem. So what does this one represent? How many are shaded? 1, 2, 3, 4, 5, 6, 7. Out of how many total? 8. Minus 1 is shaded out of 1, 2 total. Equals 1, 2, 3 are shaded out of 1, 2, 3, 4, 5, 6, 7, 8 total. So 7/8 minus half equals 3/8. By the way, what is half of 8? Half of 8 is 4. So 1/2 is the same as 4/8. So 7/8 minus 4/8 is 3/8. 7/8 minus 4/8 is 3/8. Same thing. Now let's work these without a picture. 1/5 plus 3/5. Okay, right. Make sure you write the problem. 1 plus 3 is 4. Keep the denominator the same. 4 out of 5. 4/5. Okay. Number 4, we have mixed numbers. Now, with mixed numbers, you can keep them mixed numbers only when you're adding and subtracting, not when you're multiplying and dividing, okay? But it's easier for me to do this vertical, so I'm going to rewrite the problem vertical. Okay? Always start on the right with fractions first. 9 minus 3 is 6. The denominator stays the same, 10. And 3 minus 1 is 2. Or I can reduce 6/10 by dividing both of these by 2. 6 divided by 2 is 3, and 10 divided by 2 is 5. So 2 3/5 I can get for that one. Next, 2/9 plus negative 5/9. Well, they have the same denominator, so 2 plus negative 5. 2 plus negative 5. So I'm going to use algebra tiles here so you guys don't forget this strategy. 2 and negative 5. Zero pairs. I have negative 3. And the denominator stays the same. Negative 3/9 To reduce it, you can divide both of these by 3. Negative 3 divided by 3 is 1. 9 divided by 3 is 3. Negative 1/3. One-third minus 1 4/5. For this one, since I don't have a whole number here, here's no whole number, right? I don't have anything there. Nothing. Look, nothing. Since I don't have a whole number there, I know I'm subtracting more than what I have. So I know my answer is going to be negative. If I only have 4 and I take away 8, I know my answer is going to be negative. Well, here you don't have any. You only have 1/3, just a fraction. And you're minusing 1 whole. That's more. Since I'm subtracting more, I know it's going to be negative, so I put a negative right away so I don't forget to do that. Okay? I'm going to go ahead and change 1 4/5 this time into a fraction. It'll just be easier for me. So I'm going to multiply and add. 5 times 1 is 5 plus 4 is 9, 9/5. So I have 1/3 and I'm subtracting 9/5. I need my denominators to be the same. Okay? So I need to change my 3 and 5 denominators to a common denominator. I need to find a multiple of 3 that is also a multiple of 5. In other words, when I count by 3s and when I count by 5s, I have to keep going till I get the same number, and there we have it, 15. So I'm going to use a common denominator of 15. What did I multiply by 3 to get 15? 5. So I multiply the 1 by 5. So that's 5/15. 1 times 5 is 5. Now the 9/5. What do I multiply to get 15? 3. So I multiply the 9 by 3. 9 times 3 is 27. 5 take away 27 is going to be negative for sure. What's 5 take away 27? If I have 5 positives and 27 negatives, and I make 5 zero pairs, what's left? 22 is left. So this is negative 22 over 15. Okay. If I want to change this now back to a mixed number, I divide 15 into 22. 15 goes into 22 1 whole time, so I know my negative 1 whole. 15 times 1 is 15, subtract. 12 minus 5 is 7, 1 minus 1 is 0. I have 7 left over, that's my leftovers, and my denominator is 15, so I keep it 15. Negative 1 and 7/15 is my answer. Now this one. You're going to count by 7 and 3s until you find a common denominator. 3, 6, 9, 12, 15, 18, 21. I think that's going to be it. 7, 14, no 14 here, okay. 21, there we go, that's it. So we're going to change these to denominators of 21. What did I multiply by 7 to get 21? Then what do I have to multiply by 5? Same thing. 3 over 3 is equal to 1. So 5 times 3 is 15. So that means that 5 over 7 is equal to 15 over 21. Okay? What do I have to multiply by 3 to get 21? 7. 7 over 7 is equal to 1 whole. So 2 times 7 is 14. 3 times 7 is 21. That means 2 over 3 is the same as 14 over 21. Now I can subtract. 15 minus 14 is 1. The denominator stays the same. 1 over 21. And we're just going to do one more and then we'll be done. Variables. My denominators are already the same. Yay, I can already do that. What's negative x plus 3x? What's the coefficient with negative x? 1. So negative 1x plus 3x. So I know I'm going to have an x. Common, these are in common, right? So I'm just combining like terms. They both have x, so they're like terms. Negative 1 and 3 positive. Make your 0 pairs. What's left? 2 positive. Okay? I can divide 2 and 4 both by 2. So let's reduce. 2 divided by 2 is 1. Well, 1x is the same as just x. And 4 divided by 2 is 2. So I have x over 2 is my answer. All right, you guys, we're done for the day. That was only 10 minutes, 11 minutes, so we're good. Have a great day. Talk.